Have you ever wondered how things like credit cards or smartwatches work? These are all efficient things, but this efficiency is caused by a little known field called relational algebra. This is the study of databases and tables. You can also join tables and perform several operations in them. Previously, doing the task we mentioned would require several librarians and a few weeks to complete. But now it can happen in a few milliseconds with modern technology and relational algebra. So, in this video, we'll have a breakdown of how relational algebra works and how it is used in efficient models. Relational algebra is the study of tables and databases. It is also the study of how the properties of tables are changed. For example, there's an operation called a natural join. This joins two tables together. If you had a table, Alice and Bob, and their jobs were math and science, and you had another table where you also had Alice and Bobby, but you had an ID, that unique ID table will be assigned, adding an extra row. Additionally, there's also the project operator, which can select a row, and there's also the rename. The rename will change the name of a row. For example, if you had two tables, alias and name, you could rename name to alias, or vice versa. So, we will take a look in how the natural join works in other fundamental toolkits of relational algebra. Say you have two tables and you want to reorganize them. You have table A and table B. You will transfer some of the items that meet a certain requirement from table A to table B. You use the natural join formula. This is equal to the projection operator and the selection operator of how many rows. In this example, we're using 5 times 0 rows, but we'll be using a different row for our micromanagement table, which we'll create. We will assign an item name and a cardinality, or how many items are in there. Each row corresponds to its column. So, there are 5 papers in one box, and so on. We can create a logical statement using ANDs, so we know 5 equals 5, 1 equals 1, and so on. And 5 does not equal 2, 5 does not equal 10. So we eliminate these rows from existence, and then we have our final result. There are 5 bags and 5 papers. Now, the world is efficient because of relational algebra and how it stores data. Back to our previous analogy, when we said taking a task that would be effortless today would take a team of librarians in several weeks, we can see that if they made a single mistake, they wouldn't be able to update it, since relational algebra wasn't back then. But now, due to complex computer algorithms, we can effortlessly sort data. So, the world has become efficient, all due to relational algebra and discovery of math.